In this video, we're going to look at acids and alkalis. We're going to cover what acids and alkalis are, then look at pH as a scale for measuring acidity or alkalinity, look at some indicators, as well as the neutralization reaction. So firstly, acids are any chemical that when dissolved in water, the two ions dissociate, and one of those ions is a hydrogen ion. So we have these positive hydrogen ions floating around, and that's what makes the solution acidic. So for example, hydrochloric acid, when dissolved in water, produces hydrogen ions as well as chloride ions. Acids can be corrosive in that they can burn the skin, and they are sour to taste. And many sour foods contain naturally occurring acids. For example, lemon juice has citric acid, while vinegar contains acetic acid. Alkalis, on the other hand, are chemicals that when dissolved in water and dissociate, they produce hydroxide ions. So sodium hydroxide is a common alkali that we use. When dissolved in water, it produces a positive sodium ion and a negative hydroxide ion. Alkalis can be caustic, which means that they also burn the skin, but they do it in a different way. They are bitter to taste, and we often use alkalis in cleaning products. For example, bleach and drain cleaner both contain strong alkalis. pH is a scale that we use to measure how acidic or how alkali a solution is. If a solution is very acidic, it will have a low pH, so a pH of somewhere around 0. And this is because it has more hydrogen ions than hydroxide ions. If a solution is very alkaline, it will have a high pH, and the scale only goes up to 14, so it'll have somewhere around 13 or 14. And it has much more hydroxide ions than hydrogen ions. If the hydrogen ions and the hydroxide ions are equal, the solution will be neutral and the pH will sit in the middle at 7. Now pH is a log 10 scale, which means that for each whole number that you go up, you're actually getting 10 times stronger. So for example, an acid which has a pH of 3 has 10 times as many hydrogen ions as an acid that has a pH of 4. An indicator is any substance that changes color in solution of a different pH. Now, one of the most common indicators we use is the universal indicator. And the reason that we use this is because it can show specific pHs because it has many color changes on the spectrum. It starts off red at the strong acids, so around 1 it'll be red. Once it gets to neutral, 7, it will be green. Then in very alkali, so up around 14, it will be purple. And there's multiple color changes that happen between these different stages. So we can actually tell using universal indicator the difference between, say, a 3 and a 5 or a 9 and a 11. A neutralization reaction occurs when an acid and an alkali are mixed. And if they're mixed in equal amounts, the whole solution will be neutralized and have a pH of 7. This occurs because the hydrogen ions in the acid react with the hydroxide ions in the alkali. The general equation for this reaction is when an acid and an alkali are mixed, they react to form water and a salt. And the salt is going to be the ions that are left over from the acid and base. So for example, hydrochloric acid produces hydrogen ions and chloride ions. Sodium hydroxide produces hydroxide ions and sodium ions. So the hydrogen ions are going to react with the hydroxide ions to form water, while the sodium ions are going to react with the chloride ions to form sodium chloride. And this sodium chloride will stay dissolved in the solution as ions. In this video, we've looked at acids which have a low pH, are sour to taste, and produce hydrogen ions when mixed with water. We've also looked at alkalis which have a high pH, are bitter to taste, and produce hydroxide ions when mixed with water. We've looked at pH being a scale to measure acidity or alkalinity, indicators that are change in different pH of solution, as well as the neutralization reaction, which occurs when an acid and an alkali are mixed, which neutralizes to form water and a salt.